Okay, let's go. Welcome to this video. It's about refactoring a Spring AI proof of concept by Josh Long that he published like a couple of months ago in his channel. And yeah, as you can see, it's a LLM RAG with Spring AI. But what is all this? LLM, RAG, Spring AI. So LLM is large language model, a type of artificial intelligence model designed to understand and generate human-like text on the input it receives. Example, for instance, I think that everyone knows ChatGPT. What is a retrieval augmented generation? AI framework that helps LLMs to provide more accurate responses by retrieving up-to-date information from several sources such as databases or internet. And what is Spring AI? It's a framework for AI engineering and is currently in version 0.8.1. And about the repository, again, like it's just a proof of concept, again, done by Josh Long a couple of months ago, using PG Vector, that is a plugin for Postgres to be able to be used as a vector database. It's going to use OpenAI API and is using also Docker. So how it works in a nutshell, we're going to develop this service that again is a proof of concept. We are going to refactor it and is asking based on the input that we will give to the Postgres the context, and then after with the context that is stored in the Postgres database, we will ask ChatGPT to answer. So together with context plus the question that we want to make, we are going to ask ChatGPT to provide an answer. And what we want to do is what is called in microservices world a component test. So we're going to grab the near dependencies such as Postgres and the service in a sort of closed box. Then we're going to test this with a component test. Thanks to Wiremock, we're going to mock in a way we're going to simulate the request response to ChatGPT. So we're not going to call directly ChatGPT. We're going to use Testcontainers to actually simulate Postgres and PG Vector. Okay, let's have a look at the code itself. So here there is a README, quite not much information here. Then here there is service that is wrapped here entirely. Here we have Maven, obviously, Docker Compose that is using, as you can see, PG Vector. We have here the PoC. Let's have a look at this. Spring 3.2.1 is fairly up to date. I think the latest version is 3.2.3. Something like that, and as you can see, using Java version 21, Spring AI version should be 0.8.0 snapshot, but it's fine. I think the latest one is 0.8.01, and that's it. Yeah, let's have a look at the code. Side here, as you can see, first of all, there are no tests, obviously, because this is a just proof of concept by Josh Long. And makes sense to, it's completely useless to create tests, but in this case for fun we're going to refactor this. So as you can see here is in Java, service application, resources is application is quite basic. There is just username, password, and the JDBC URL for the vector store. Then there is the OpenAI key that is, as you can see, is configuration-based configuration to connect to OpenAI, and is already configuration from Spring AI. There is the starter, well anyways, there is the auto configuration. So it will do some stuff for us that maybe we may not like. And let's go to have a look at this. So this is the typical Spring Boot application. Here there is the typical main. Obviously for convenience, Josh Long add everything in the service application. So all the beans with the definition of the vector store, blah blah. Everything in here, and also the init, that is a starting method that is called by the application runner. The application runner so has this value that is the PDF, desktop PDF, medical blah blah, that is instead outside here, is not in desktop, so we need to fix this path to make it work. Then there is a response from the chatbot, so we are initting the database, vector store with JDBC template. And in the init, we are cleaning up every time the app runs the vector store. Then we are reading the PDF that we get from, this is the configuration for the PDF document reader. Then we do PDF resource. Where is this? Okay. We get the PDF resource from the desktop in this case, we need to fix the path, and text splitter, okay, nice, and then we do, okay, we are inserting the PDF in the vector store every time the application runs. So we delete, we do all the configuration in the PDF file, we split in token, as far as I can see, and then we store in the vector store, so in Postgres. This is the first init. Then now we ask the chatbot with this chatbot that is a server is okay, it's here. Now we're going to take a look. We're going to ask this question. So the question in this case is static. There is no API. It's just when the application runs, we're going already to ask the chat to, in this case, ChatGPT, to answer this question. How the context is given, so how RAG is working, I guess, is inside chatbot. We're going to see. Then the response, we're going to print it out here. Quite simple. This is problematic, obviously, for testing. This is going to be a thing that is a bit hard to test, but we're going to see some way to do this. Go to our chatbot. This is the template. Okay, nice. This is the context that we are going to give to the chat. So we're going to, okay, this is the text, and then documents. We're going to interpolate the documents. So the PDFs that we are storing into the vector database, we're going to insert this and give this template to the ChatGPT API in this case to give context. Okay, so the chatbot, okay, there is the AI client that is from Spring, as far as I remember. Yes, nice. And then here the chat method, that is this one that we are calling here, is, okay, we're going to search. Oh, this is nice. So we're going to search in the vector store documents that match this message. The message is this one that we are giving to the chat. What should I know about the transition to Consumer Direct Care Network Washington? Okay, so the vector store is intelligent. In theory, is going to retrieve some documents that are similar to the message that we are going to ask also the chat. So it returns documents, and we create then the user message here, and we create a new prompt with the system message that is the template plus the document. I love this because it's merging the user message, so the initial question that we are giving to the chatbot plus the system message that is basically the template that is here, plus the documents that are retrieved from the vector store. Thanks to that, then finally we are going to call ChatGPT in this case, so the API, this chat client, perfect, and we are going to get content and return here. In this case, we are going to print the response. I see a couple of problems here. Obviously, the fact that the application runs and already calls the chat. So to run the application needs the vector store, obviously, and somehow in this case the chat, so OpenAI API already Wiremocked, let's say, thanks to Wiremock. Okay, now we're going to try to run this. So first of all, we need to the Docker Compose to run. Perfect. Okay, what we need now is the OpenAI key. We have already in the OpenAI.sh, so fine. Try to run from here. So let's try to run from AID. Okay, as we said at the beginning, the application is trying to access to the desktop PDFs, blah blah blah, but obviously it's not found in this path. So let's go try to quickly fix this. Let's try again. Okay, like this. Let's try again. In theory, should be able to connect to OpenAI. Here it is, the response. So you can see answering us with this CDWA, us replace, blah blah. Okay, nice. So this is working. If we were able just to obviously configuring everything changed. Environment variable was not the same, so I need to change it. Changing the path here using Docker Compose, the file that is here, this one, running this. So a few changes and it's working. The problem is testing this. Let's see how we can do it. Okay, before starting refactoring, obviously what I want to do is covering the application with tests, right? So here there is a test, but we have seen that it's empty. It's just run the application like as we did in local environment. So this test I think can be deleted. Another thing that I'm going to do is going to create this Kotlin, and I'm going to switch to Kotlin in this case, not the production code, but the test, because why not? So I'm going to create a test, maybe a component test, so this is similar as an acceptance test or functional test. Kotlin file, yeah, good. So yes, nice. Okay, this added already something out Kotlin here, perfect. The magic of IntelliJ, nice. So in this case, we're going to do fun. This is the beauty of Kotlin again. Shoot, chatbot up shoot. Okay. In this case, we do this. Okay, it's passing obviously the test, but it's empty. Obviously that is passing. Okay, so we have test created. So in this case, we're going to use springboot test because we want to run the whole application and test it as some sort of closed box. So we're going to see if this is possible. Let's try to run this again. We're going to encounter for sure some problem here, or not. Okay, still correct. There are no errors here, but there is a problem that we are using the database that is in the Docker Compose file, and also we are calling the real OpenAI API, which we don't want, obviously. In this case, we are going to use Wiremock to mock the request to OpenAI, and you are going to see how to do it. Sadly, in this case, we are not, again, it's like there is no possible assertion here because everything, I don't know if you remember, but here, in the moment the application is running, it's doing everything. So even the answer should be here, somewhere here. So it's very difficult for us to assert the response because it's a print. We can do some magic here, but we're going to fix this in some other way. So now there are two things to mock. One is OpenAI. We cannot, again, run our test every time and expecting that OpenAI is up, and we cannot call OpenAI API all the time. So what we're going to do is add one dependency that is called Wiremock, and in this case we're going to add this scope test. We're going to add Wiremock. Let's call again. Okay, some magic needs to happen here. So in this case, to make Wiremock start before the application runs, because again OpenAI API is called before the app is running, so we need to simulate the response from the API calls. So I already prepared this. Now I need to create here we create Wiremock, the directory, and then inside we put these two files. Okay, so we create this file that is OpenAI embedding response. It's the first API call that we do at the very beginning. Perfect. And then we create the other one that is this one, OpenAI completion response JSON. Perfect. So that for the content, I'm going to copy from somewhere else. Completion. Okay. One. Embeddings. This is again the very first call that we do to OpenAI. Perfect. So we have these two. So we need to tell Wiremock to create two stubs. That one is the embeddings API and the other is completion API. So this is going to be the response from the second call that we do. That is the one that is visible here inside chatbot. So PI client called prompt. This is the one, the response that we are going to test. Okay, let's try to run again. If I didn't fail, let's see at the very end. Still, we are getting the response from this response from OpenAI. Instead, we are expecting another kind of response, that is the completion. So this is a test. We should see this is a test. So when we will achieve that OpenAI, so to stop, let's say using Wiremock, the OpenAI call, the response, sorry, then we will see this is a test as a response here. But right now we're still calling OpenAI. Let's try to achieve this. Okay, let's add the thing that is missing, that is the Wiremock port, overriding this OpenAI base URL to localhost 7777, that is the Wiremock port, that is also this. And now in theory we should be able to see in console that this is a test should be the answer from Wiremock. So we're not going to call anymore and spending money calling the real API from OpenAI, but we will see this is a test finally. Let's see. Yes, this is a test. Nice, we're not calling anymore OpenAI. Okay, now next step is to start to assert something, right? We know that we are creating a stub for OpenAI response, and the next thing that we need to do is try to test this, assert that the response here is what we expect. So this is a test. The problem with this is that this is very difficult to test. There are ways to capture the output, but the console right now is adding too much output, so it's difficult to test. So what we can do here is try to wrap this into something else. So let's create here something like a printer, Java class, console printer, that does basically what it's doing here. This is a way to isolate. That is very difficult to test the system out println. So we're going to do this, and we're going to replace this for the printer. So let's do another here, printer, console printer in this case, printer. Nice. Then we're going to replace this. In theory, we can do this. Obviously, this is not going to work like this because it's still using the real console printer. Then what we need to do is overwrite the mock here. Okay, let's now use mock bin to start mocking the console printer. Perfect. Now inside this, what we need to do not sync. Nice. And also we're going to mock it to verify. Let's actually make it fail for the first time. Let's go to run the tests. Perfect. Fails. Now if we fix this, run again, it works. Nice. Perfect. Then we mock the printer that is here. Then the next step is to actually mock the database. So instead of using Docker Compose, so the PG vector from Uncanny is running, what we're going to do is going to use Testcontainers. Testcontainers is already here, new dependency already added, perfect. Then what we're going to do, we're going to configure Testcontainers. I've also added already in this configuration to actually start up the Postgres container. In this case, we put this one, but we will need to change it. And also in this case, we are telling that we are going to override Spring data source URL, username and password. Now let's copy this, see if this is going to work. Change the image here for this one from the Docker Compose. Then database name here is user and password Postgres. Let's see if this works. Okay, failed. Okay, failed, but I found an alternative that is this one. This seems to be a bit more stable. PG vector and is compatible with Postgres 16. As you can see, substituted the version of Docker image. Will be private. Perfect. Now let's run the test. Okay, so it was failing because basically the container is slow, needs some time to boot, and we can use this wait for listening port, and that's it. Let's try again, just to test that the test is not flaky. Nice. Okay, so quick overview before we start. So as you can see, we created a huge test with a huge configuration. So we need Postgres, the container, with some configuration. We need Wiremock. We need to start Wiremock before springboot starts, because this is how Spring AI works. On the other side, we didn't modify almost anything. We just added a console printer in order to be able to wrap the system out here inside and be able to mock this dependency, this component. So in theory, if we also run this test, say all the tests with coverage, we have almost 100% coverage. So this is a way to be sure that with a legacy project or proof of concept, etc., we want to cover with tests. This is also a way to understand if we cover everything or not, if we are covering all the possible cases. Okay, coverage 66. Okay, 1% here. Let's open this. So we're covering almost everything here. So you can see the bin here we're not covering. So all covered here. The Spring Boot obligation we're not covering is fine. And what we are not covering is obviously the model, because we are mocking the console print. We could test this separately, but to be honest, doesn't make any sense in this case, because at the end, while we are going to refactor, we're going also to most probably remove this console printer.